First of all, I would like to express my gratitude, my appreciation for the organizing committee for allowing me to have this talk here. Second, an apology to the administration, the organizing committee, and all the audience. I thought I did not realize that the timing is exactly when I have an exam and a class in my university, which I just cannot leave. So I am sending a pre-recorded presentation, and I had really wished that I was there with you, but I will not be. I'm sorry. So welcome to this presentation on swell packers and expandable tubulars in petroleum drilling, finite element simulation. My name is Sayyid Zahid Qamar. My co-authors in this work are Maaz Akhtar, Farooq Jahvari, Tasneem Parvez. We are at the Mechanical and Industrial Engineering Department at Sultan Qaboos University, Muscat in Oman. And we belong to a research group, Applied Mechanics and Advanced Materials Research Group, which we say is AM²R group. Before we can start, I just want to invite you for some future events if you come to Oman. Oman is a very beautiful place. Have a few looks at it. This is another set of some views. People think that it is only desert and so on, but there are beautiful mountains and valleys and a lot of sea and great architectural places. Another view of Oman. My city, Muscat, the Corniche area. And this is my university, Sultan Qaboos University. Again, a very large and picturesque place. Another view of Sultan Qaboos University. One more view. So in the future, please be on the lookout for some conferences and so on, which we might have organized here or the country in general. Now, before the actual topic, I would like to start with a quote by A.R. Dykes. Engineering is the art of modeling materials we do not wholly understand into shapes we cannot precisely analyze so as to withstand forces we cannot properly assess in such a way that the public has no reason to suspect the extent of our ignorance. So that last part is a bit of levity, but that is what we actually do when we are doing some cutting edge research at the very frontiers of technology or science. Then there are things which we really know and there are things which we do not. What was the motivation behind the current work and what is its significance? Swelling elastomers in oil and gas drilling. Swelling elastomers are a very recent development in the world of advanced polymers. They undergo dynamic swelling when exposed to water or oil or acid. And they have been successfully used as packers, swell packers, and other sealing elements in various oil fields. A swell packer is something that consists of a swellable elastomer section or sections bonded to petroleum pipes, which we call tubulars. Major applications: zonal isolation, shut-off, slimming down of oil wells, making oil recovery possible from difficult and abandoned wells, etc. So these swelling elastomers and swell packers are really doing a lot of new job which people thought could not be done, and they were abandoning wells, and now they think they can extract oil again from those wells. So I'm showing you just a few pictures. This is a swell packer. This is a cutaway section, the rings and so on. In a horizontal well, they do vertical drilling and then they do it horizontally. So this is a swell packer, this is a swell packer. This is a perforated petroleum tubular from where the oil will be going up from the reservoir up. There are lots of issues here when we do this type of a modeling on simulation or experimental work. Environmental conditions can be different. There could be oil there, or water of different salinities, or acid of different concentrations. The temperature could vary as we go down into the earth. the properties of the formation or the rock would be changed, and the differential pressure of the oil around the swell packer would be different. So this rubber will start to swell, right? Day 1, day 2. After some time, it will swell and completely fill up the space, and it will be sealed completely. Other variables, the seal thickness can change, the length of the sealing element can change, the gap between the elements. This is one packer, this is the other, this is the other. So what will be the gap? The number of sealing elements. So when we do these experimental investigations and we do these numerical simulations and so on, then there are lots of very challenging parameters that we have to model to create the real scenario. Elastomer research at Sultan Qaboos University, right? So we have done several research or service projects basically on the theme of performance analysis of elastomer seals in oil and gas wells. Sultan Qaboos University and Petroleum Development Oman, which is the main company in the country, and then other companies in the Gulf region. So Petroleum Development Oman, Shell Oil and Gas, Baker Hughes, Mask Oil Qatar, Ruma Rubbers Holland, Swellfix Tendika. We have agreements with lots of these companies, non-disclosure agreements and so on, to perform certain research or service projects with them. The major goal, as I said, performance evaluation and design improvement of water swelling or oil swelling elastomer seals and swell packers in downhole petroleum applications. The methods and techniques that you use: modeling and simulation, analytical modeling, numerical modeling, mostly finite element based, some statistical stochastic modeling, experimental investigation for performance evaluation, material characterization of the rubbers and so on. So lots of different types of studies have to go hand in hand. The target benefits of these type of research: pre-qualification or proper selection of suitable elastomer materials and packers for a given set of field conditions. Some packers are good in one type of oil well, some other packers would be better in some other type of oil wells. So if we can select the proper ones before we use them, then the chances of success really increase. Improvement of sealing or packer design, evaluation of seal integrity, will the seal last for a long time, and of course modeling and simulation of swelling elastomer applications in different kinds of actual oil and gas drilling situations. The types of studies that we have done, lots of them have been there: performance testing, reliability testing, numerical modeling, analytical modeling, material modeling, and so on. So let us go to a little bit of introduction of what we have been talking about. This is conventional drilling. Conventional drilling. Drilling starts using a drill bit with a large dia, 36 inch. A steel pipe known as casing is run into the ground. After the drilling is done, a steel pipe is sent in. Gap between the pipe and the formation, the rock formation, is filled with cement to isolate different zones of rock, water and gas and so on. So you drill, then you in the hole you send a pipe, and then you cement it in place. Drilling is continued, repeating the same steps using a smaller drill bit each time. So now you have drilled this much. Next time you will send this pipe which goes inside and again cement it. Next pipe you have to send this pipe. So this telescopic effect goes on, telescopic well design. Finally, the actual production pipe is only 5 inches in dia or 7 inches in dia, which is going up there. So this is conventional oil and gas drilling. They are trying now for slim well design, that rather than starting with a very large dia and going to small, can we have almost the same dia throughout? This will be called a slim well design, and this has been made possible by something called solid expandable tubular technology. Solid expandable tubular technology. And SET technology always works together with elastomer seals. So I am just showing you that in a conventional plan and a slim well plan, right? The conventional plan starts with this very big hole and comes to this. Slim well plan starts with a much smaller and goes like that. So there is huge amount of savings in drilling and mud removal and water and steel and all other resources. Water shutoff or zonal isolation. Water shutoff. In some places, oil is there, but suppose they detect a water producing zone. So now if this water goes inside with the oil, then the oil that comes in is mixed with water, and this is absolutely not acceptable. So in this zone where they have detected water, they will set this swelling elastomer, and once it hits water, it will swell and it will seal off all this zone. So the water will now not do any incursions into the oil zone. This is called water shutoff. Similarly, if there is oil of one kind, one viscosity, and another viscosity oil is trying to mix up and they detect it, then they would send these elastomer packers to shut off the other producing zone. So in case of water, it is called water shutoff. In case of other types of isolation, it is called zonal isolation. So these are major uses of these things. Other pictures for the same thing. They can also, as I was mentioning, that cementing is done. Now we can remove some cementing, and instead of the cements, we can use swelling elastomer packers. So this is another major use where we can reduce cost and time and so on. And these are other pictures and so on. We can go back to this later on if somebody is interested. So with that background, that what are swelling elastomers and how are they used in petroleum drilling and so on. So what are we doing at Sultan Qaboos University in terms of elastomer testing, characterization and so on? Before we go there, Henri Poincaré, major scientist, science is facts. Just as houses are made of stones, so is science made of facts. But a pile of stones is not a house, and a collection of facts is not necessarily science. We do a lot of experimental work, and this is very true for us, that you see, you have done a lot of experimental work. First of all, it is very difficult to arrange it, to design the experimental facilities and to perform all the tests. But at the end, if you have a lot of results, then unless you can join all those results in scientific reasoning, these are a pile of stones. So in the swelling test, we have to make some disc samples, some ring samples, some plate samples. We start by taking a swell packer from the oil industry, remove the rubber, right? Remove the rubber from it, do some surface grinding on the rubber, make special jigs and so on, so that the glue area is gone. Cut them into different pieces, grind it, cut the rubber into different pieces, use these punch and die systems to make the discs and the rings and so on. So before you start, you have to do a lot of things. There are tests which are called compression set tests. So in accordance with ASTM and ISO guidelines, we designed and manufactured our in-house jigs and fixtures to do the compression set tests. There are tests which are called tensile set. So again, with ISO and ASTM guidelines, we designed and fabricated our own jigs and fixtures to carry out these tests. There are swelling tests. We have to swell the rubbers in different kinds of oils and waters and so on, and keep the salinity for a long time. So we have to have a lot of sealable glass jars and servo controlled big ovens and so on for the swelling experiments. In swelling experiments, we measure different things, their weight and density, and especially we constructed this equipment to measure the volume by displacement method.